Intellyx Brainwave Problem Solvers. Why is multi-tenancy hard? With Prasad Dorbala of Avesha Systems.
Cloud native, SD-WAN, analytics, machine learning, agile development and testing, edge computing, DevOps, service management, enterprise architecture, hybrid IT, neural networks, cybersecurity, serverless, low-code, no-code, big data, integration. You're listening to the Intellyx Podcast, where we bridge modern and legacy technology and untangle the buzzwords to help business and IT leaders connect the dots to achieve digital transformation. Disclaimer: the perspectives expressed in this show are the independent opinions of the hosts and/or guests and do not necessarily reflect the position of Intellyx or any companies mentioned here. And now, your hosts, Jason English.
Welcome to another Intellyx Brainwave Podcast. This is our Thought Leaders Problem Solvers episode, where we talk about some common problems that exist in the cloud native ecosystem and what we can do about them. So today I have Prasad Dorbala. He's the co-founder and chief product officer for Avesha. You might know of them better as the people who make the CubeSlice product, which is a multi-tenant, multi-cluster networking and orchestration solution. So good to have you on, Prasad.
Thank you, Jason. Good to meet you.
Prasad, I think let's just start off with the fundamental issue. It seems like Kubernetes itself and a lot of the tools surrounding that were supposed to solve the orchestration problems, and they do to a large extent. And then the whole promise of cloud in general is really multi-tenancy. So why has multi-tenancy for Kubernetes environments become such a hard problem to solve?
Yeah, thanks, Jason. Kubernetes has done a phenomenal job in orchestrating containers. Everybody is containerizing their monolithic applications to microservices, and the de facto standard for orchestration is Kubernetes. And containers are growing at a 32% CAGR year over year, massive growth. So Kubernetes was all driven from an enterprise viewpoint, right? So enterprises have certain behaviors. Enterprises have users, and users in an enterprise have a trust behavior, right? So most of the enterprises, the users are all employees of the same enterprise, so there is a mutual trust associated with it. But when you start to extend that Kubernetes deployment as a SaaS solution for different set of users, then there are challenges in the way Kubernetes has been designed, right? The control plane is common in a cluster. So now you can argue saying that, hey, why don't you spin up multiple clusters per enterprise? Yes, you can do that, but that actually goes into a whole notion of cube sprawl, right? There are many cube clusters which are getting spun up per enterprise, which actually means you get the multi-tenancy for free by doing, multiple clusters. But as the scale grows up, tens and hundreds of clusters, then managing them is a big challenge. And then also the fact that you have to spin up a cluster per tenant or clusters per tenant, you're not efficiently using the resources which give you the benefit of running Kubernetes, right? So that is the reason why people are considering how to do multi-tenancy in a single cluster, and then extend that multi-tenancy across multi-cluster so that, when the demand comes in and then you add more clusters, that tenancy which is defined in a single cluster should extend rather than re-provision it. And these clusters are ephemeral too, right? So once they come and then go, you don't have that much time or configuration challenges. And then essentially, when you have all these things, you also add the visibility tools which you put it in, right? The visibility tools are different for a different tenant. All of that needs to be orchestrated and then becomes a big challenge, Jason. That is the reason why industry is now the success of Kubernetes is driving some additional features which needed into the foundational of Kubernetes.
Mm-hmm. It's almost like this mentality of being able to use open source solutions combined with what you have, roll your own clusters for the needs of different customer groups, has kind of created the situation that we're in right now, right?
That's
it was
right.
a very positive thing to allow infrastructure to be responsive to the needs of the business and business users in the end, but it created this new problem. So how do you address this use case?
Yeah, it's a very important factor from a cost and efficiency standpoint. Now, first of all, we need to understand what is tenancy, right? Tenancy can be deemed to be in many grades. Mm-hmm. Let's say in an enterprise, as I talked to you about, a tenancy can be for an application. There are certain set of applications which are very critical from a revenue generation standpoint and a security posture standpoint. They need to be isolated from other set of applications which are kind of generic in nature, right? So the tenancy is a type of an isolation, right? It is an isolation. Then you define an isolation. Isolation in an enterprise is different from isolation across multiple enterprises. And then isolation is different for application. So in order to do that, there are many, many knobs you need to establish for all different types of isolations, right? And then essentially, fundamentally, Kubernetes has a control plane, which is common for every cluster, right? Control plane is common. And then as well as some of the resources like nodes and other things are very common to cluster, right? When you talk about isolation, what is to say that a tenant brings their own container and, for no reason or some, situation where they have included third-party, software into that container, it may have some malicious content, which they're not purposefully doing it, but they have packaged in there. So now, do you have a collateral damage for somebody else sitting on the same cluster, right?
Right.
So how do you isolate them from a pod point of view? How do you isolate them at a construct called namespace? Or how do we isolate them from a control plane standpoint, right? So that when they use all these tools like kubectl and others, they're only seeing their part of the infrastructure rather than the overall part of the infrastructure, right? So there are challenges there, right? And then that is what we are trying to solve. And fundamentally, there is a construct called namespace, which is unique per cluster, right? You cannot have the same namespace in the cluster, two different things. But when you give an access to the infrastructure, they may call a namespace called JSON, and somebody else might call the namespace JSON. But if they happen to be on the same cluster, that is not allowed. So there are lots of challenges like that. When you want to do a true multi-tenancy, we need to overcome in Kubernetes.
Yeah, it seems like we were expecting when we were talking about the infrastructure being so ephemeral, containers and pods and everything coming and going, that might solve this kind of noisy neighbor problem that we usually have with conventional architectures, and maybe that would have gone away. But actually, even the consumption model for the resources is still kind of constrained by the fact that different people are using it in different ways, and it's probably not optimal, right?
That's right.
Even beyond just the security concerns, how do you kind of solve for some of that?
Yeah, so that's an important factor, right? You hit it on the head, noisy neighbor problem, right? Mm-hmm. Especially when you have a tenant which is, Coke versus Pepsi, like at different enterprises, right? Running on the same cluster, right? How do you shard such a way that a designated set of resources are allocated to a tenant so that, they may be running on the same node, or they may be segregated on a different node. There is a network resources which need to be isolated. There is the compute resources which need to be isolated. And then there is also a whole notion of storage components which are tied, which are common. PVs are kind of common for clusters. How do you associate it to a tenant? Those are all fundamental challenges which need to be solved from a multi-tenancy standpoint.
Mm-hmm.
Right?
Yeah. So this is very interesting. And so how do you kind of solve the problem of having workloads that are able to cross multiple clusters, or even, so are you saying that they could cross multiple namespaces that are in different, so that concept is sort of your overarching goal, right, is to be able to even have the infrastructure cross multiple namespaces, multiple instances, even different cloud services, whatever. How does that happen?
Yeah, so that is what CubeSlice is trying to solve. What we have is created an abstraction on top of the existing Kubernetes infrastructure, and then we call it a slice. A slice is a collection of namespaces wherever they are, right? So you rightly said, Jason, positional location is important too, right? With the advent of edge computing coming into play, you need to have a workload closer to the customer so that customer can have the best quality of experience. So then your kind of hyperscalers may be in one location. Now you have edge, which is coming where the customers are, then that's another cluster. So combining these things and then making sure that the tenancy is maintained across multi-cluster is an important factor in the industry coming up. That is what CubeSlice is bringing, is to drive the tenancy, true tenancy in a cluster, and then extend that tenancy across multi-cluster in a seamless way, right? So such a way that the consumption of people who are actually deploying applications are focused on the business logic rather than the infrastructure logic. We take care of the harmonization of tenancy across multi-cluster. See, one of the fundamental problems when you are crossing two administrative domains, right? Mm-hmm. You are in a hyperscaler, and then you want to have a footprint in an edge provider. So there are two different administrative domains. Yes, containers have abstracted and then made it simple for deployment anywhere, but the infrastructure need to be tied so that you can distribute the applications and then talk across these disparate different infrastructures, which are administratively different, right? The address planning, the IP address planning, which needs to happen, what needs to happen in the hyperscaler, what needs to happen in the clusters, and then edge clusters can be many in nature, right? And then also, geographically, there are multiple regions in hyperscalers, right? Think about it where somebody is actually doing on-prem Kubernetes and then tying it out with edges. That's another vector we are addressing. So those addressing schemes are a big challenge. And then we solve it so seamlessly by giving an overlay network, such a way that they don't have to worry about the addressing, they just focus on business logic. So bringing all these multi-clusters, be it in on-prem, be it in hyperscaler, or be it in edge, and then make it look like a cohesive virtual cluster is something which we bring.
Yeah, rather than waiting for, I don't think we can wait for the hyperscalers or telcos, for that matter, to solve this problem. I don't see them coming to coordination that quick. I think some people might look at what you're talking about and say, well, isn't that just another service mesh? So I think those might exist in the landscape that you're talking about. So how do you kind of differentiate from some of those approaches?
Yeah, service mesh solves a different type of a problem, right? Service mesh definitely solves service-to-service communication, but they assume fundamentally that there is a transport available, right? Service mesh does not distinguish well on tenancy part of it. Service mesh is on top of Kubernetes cluster. As long as in a single cluster, there is no construct like a tenancy inside that, right? So that is where we change a lot from a API server standpoint, how the scheduler works, what needs to be scheduled where. Those are all different than service mission, right? Service mesh mission is about service-to-service communication, visibility, and MTLS, right? Those three fundamental things they do very well. And we are kind of little lower than that, right? Which is essentially at the Kubernetes layer, not at the service mesh layer.
Mm-hmm. Yeah, so as opposed to being purely about the integration, it's really about making sure that all of these components can work together. And so there could be multiple service meshes within these landscapes. That might be your mechanism for having that service communication, but it doesn't a requirement of your solution. Yeah.
Not necessarily. In fact, our posture, essentially, if you look at 5G and other technologies, which are doing something called network slicing, and then the ORANs getting distributed and all that stuff, right, which is all Kubernetes centric, we help because the network which we bring in is not HTTP only. They have all kinds of, exotic protocols which need to be passed through from cluster to cluster. So they are layer 3 and above, right? Rather than, HTTP centric, right? The ingress egress challenges which they have, some of the CNFs, what we call cloud native network functions, are not so, comfortable with natting some of the protocols which go about. So we need to give a much easier transport across multi-cluster, because NATs are something no for some of the protocols. So that is what we bring to the 5Gs of the world to be able to help solve that problem more natively in the Kubernetes realm rather than at the service mesh level.
Very interesting. So what would you say would be the, as far as your initial set of customers and users that you're seeing, what kind of roles are looking to take care of this problem? So is it sort of like at that architect level, or is it somebody who's thinking more, or what kind of initial use cases are you seeing out there when people approach you?
I think there are multiple use cases which we are seeing. People who are really interested in tenancy of isolation across applications. And there are SaaS providers who are offering Kubernetes as a service, and they want to economize the number of clusters they have. And then from that standpoint, they want to have true tenancy, multiple enterprises running on a same, right? So that they can have a clear separation of control plane and as well as designated resources and solving the chatty neighbor problem. And then from a standpoint of enterprises who are, single region, who wants to have multi-region support and actually distribute the workloads closer to the customers, either be it at their own data center, which is essentially hybrid kind of a scenario, or consuming the new edge providers. Those are all the kind of use cases we are seeing. And the persona who is trying to solve all these problems are the new breed of platform services, right? They are offering the platform services to their business or application providers or application developers. So these platform team traditionally used to be called DevOps. Now it's kind of evolved into platform team, who are the responsible for keeping the health, lifecycle management of the infrastructure, and then making sure that the quanta of capacity exists where the business needs are. So those are all the personas we are addressing in order to solve the distribution of their workloads in a more, guardrailed multi-tenancy way.
Yeah, that makes sense, I think, because, the first one that always popped into my mind was basically like a CSP or MSP on steroids can kind of like think about like, how do I enable this without having to roll my own new Kubernetes version of this managed platform? But then when you think about it from the point of view of an enterprise, they're constantly wrangling resources to build platforms. So I could definitely see that as being a part of internal enterprise org too.
Yeah. And everybody wants to be a SaaS provider now, right? All enterprises are SaaS solutions. Now, SaaS solution, think about it. When you are a SaaS solution, you pretty much have all the customers across the globe. Now, you want to make sure that your quanta of workload is available wherever the hotspot of customers there are, right? You don't want to backhaul all of their traffic to one centralized location, but you want to be distributing that. Once you distribute that, do you distribute the full stack, or do you distribute partial of the stack which is necessary for it to be available to solve some basic business problem? So that when you split the stack and then distribute it, then comes the whole notion of how do you make sure inter-cluster traffic is harmonized, don't go a different administrative domain, right? When you have a security posture, you want to go in that security landscape rather than go into different landscape and then have all these auditing and other stuff to go through to make sure that it is safe. So how do you reduce that headache is one of the key factors from an operational efficiency standpoint.
Yeah. Well, fascinating, Prasad. Thanks so much for joining me. How would customers approach you to get started with CubeSlice or working with Avesha?
So Avesha has taken an approach. See, the platform team are pretty much consuming open source for a lot of different things. So we are open core. We have CubeSlice as an open source. The slice concept is an open source so that at least people can try it out. You can say github.com/CubeSlice. You have all the repos out there. You can try it out. And then once they try it out, they see the value. That drives us to bring the additional value of controls, additional value of simplifying how you deploy it, simplifying the configuration, and then some key values which we are bringing from augmentation to CubeSlice. So that's how we are seeing a product like from a standpoint. And then as well as some of the pain points people are seeing, especially in the retail industry, where they have different clusters in different places. And then there are also regulation issues, right? From a GDPR standpoint, let's say EU doesn't want to leave their PII information from the boundaries. Data sovereignty is one big thing. So there are policies associated with that. Some of these things are driving applications to be distributed, and we see that day in, day out.
Yeah. So it sounds like you could probably use the open source to call and build in this functionality if you wanted to, but if you wanted to look at it more from an orchestration and policy perspective, and really have observability into what's happening with this multi-tenant architecture, then you would talk to Avesha then, right?
Yeah, excellent. That's the key point, right? All of us have run large-scale operating environments. One of the key things we always say is that the team members should have their own sanity. They don't need to be waken up in the middle of the night. So, in order for that, observability is the key foundation. If you don't know how to find the root cause, you will be spending hours and hours trying to figure out where the things happened and where it died. So that one of the things which we learned from our lessons is that, it's easy to solve, but it is important to solve it forever so that it doesn't happen the same problem. So those are the things which we have looked at and then help build from an operational efficiency standpoint.
Excellent. Well, thanks so much, Prasad. And thanks everyone for joining us on the Intellyx Problem Solvers podcast today. And we'll be seeing you.
Thank you very much, Jason. Thanks for the opportunity.
Thank you for listening to the Intellyx podcast. If you have any questions or ideas for future episodes, feel free to drop us an email at pr@intellyx.com. Until next time, keep on transforming.